Now, mind you, I just took my glasses off, and here I picked this thing up to read it. SanDisk. It's so tiny, my arthritic fingers. USB-C there. Push it the other way. What do you got? Standard USB. I've used these both on my computer and my phone, and they seem to work pretty well. And they are two different communication protocols, so to speak. Well, can't get to sleep. Got up at 2:30, my usual time to poke the fire, and half the time I get back to sleep without a problem. Another half the time I don't. Well, this is I don't. I thought, I haven't done a YouTube in a while. It's about time. No, this isn't monetized in any stretch of the imagination, because I can guarantee you with my political views, Meta and Google will never allow it. Frankly, I don't care, because I don't want to depend on them. What did I come on today? Well, my idea today was just something that hit me, and I don't know why I remember this stuff, because we're talking 50 years ago almost. Nah, not quite. We'll go with 45. What am I now? 64. If I take 40 off, that makes 24, and it wasn't quite that much. And if I take 5 off, yeah, it's not quite, but not quite enough. But it's go 47 years. Sounds good. Now, if anybody out there knows a guy named Wayne Van Wee, hey Wayne, this comes from a conversation with him when he was instructor or professor or teacher or whatever they wanted to call him at Broome Tioga Bosse's up on the hill there in Glenwood Ave in Binghamton at the top. Of course, that might have been actually out of the city of Binghamton near the town. You know what I mean? I think it was actually labeled as town of Dickinson. It was far enough north. It's towards the airport, only east. Yeah, I know it doesn't mean anything to most of you, but it does. Just something that was in my mind, because at the bottom, I think, was what was it? The Hungarian Community Center, something like that. We're in a I know this is blather, but for the region, it's interesting anyway. For those that care about such things, we used to have little community centers all over the southern tier. Jewish community centers, Italian and Catholic, and this and that. Little community centers everywhere. And the funny thing of it was, here I am years later listening to people scream about racism all over the country, and I'm sitting there. There was some racism down here, but we couldn't have racism. And if you did have racism, it was because we did have community centers and communities that separated themselves from everybody else. But they'd come out, shop, and work, and do everything else as if they were Americans. Kind of the great melting pot. From one, many came and made one. One from many. Yeah. E pluribus unum. The idea of plurality as one. It was an interesting time. Today you're going to say, bah, bah, bah. No, you're an emotional freak fit if you complain about any of this. Let's see what we've got here. Live chat. Welcome to live. Hey, guy. What's up? Where am I from? New York State. Southern tier of New York State. Flood region, New York State. Flood region that can flood without the river flooding, New York State. True story. Anyway, the title of this thing pretty much is going to be Your Tractor Governor and You. And it doesn't matter if it's gas or diesel, the exact same thing comes in. Looks like I got 5 people in there. Thanks, folks. That's cool. Now, the idea of this works for lawnmowers. Trust me, anything that actually has a governor. Now, there's going to be some differences here and there. But one of the things that it hit me when I was at Cummins Northeast and we were playing with electronic governors on N14 and M11, as we used to call them. M11 was 11-liter engines, N14, 13.8 or 9, depending on who is counting. So they called it the N14 engine, 855 electronics. Select Plus, They didn't have an IS series. Select Plus was the end of the N14, but then there was the ISX engine, the Signature. That was a X15 liter. We started playing around with all this electronic stuff. I think I ran into one electronic L10 Select and quite a few Select Plus L10s. Well, no, was it? No, they were M11s. The L10, there was only a few Select electronics out there. But when we go into features and parameters while we were working on the computer, I'm poking away and they were teaching me some about it. And I was familiar from working with fault codes on cars. You had a little breakout box, plug the thing in and it'd beep out a code. You're like, boy, that's old school. Yeah, but at the time that was very common. We're talking 90s. And it'd beep out a code, say a 23 or a 45 or whatever, and tell you if it was a particular sensor or problem with the timing, maybe something else. But it really wasn't all that specific. It just told you what particular sensor system was the problem. But for us, when there was only 3 or 4 sensors on the entire car telling the ignition system what to do, and occasionally how to handle the fuel management, not very often, but it did occasionally tell you your oxygen sensor or something was off. But that was it. But I was familiar enough from that and troubleshooting from those numbers and the systems to work with it when I got there. It wasn't that huge a transition. And they were kind of surprised that a 39, 40-year-old guy wasn't stuck in his ways and was enjoying the computer end of it. So I looked and there was what they called droop, but we were working with the cruise control, highway speed. And it snuck over in my mind, governor. And they used to have what they had a constant speed governor and a road speed governor. Well, road speed was off the speedometer and constant speed was RPM of the engine. But the controller had both that was on the engine. And they had upper droop and lower droop. What's with that? Well, the majority of the machines I worked with were road speed style governors, the N14s, the Select Plus. And then we got into the IS and QS engines, which is integrated systems, Cummins, and integrated systems or quantum systems for the industrial side. In other words, off-road and on-road, essentially, between the two. Because on-road had quite a few other additions that they'd have to add into it, so they had different software programming in general, not specific. But their governors were different. One ran off road speed, as I said, and the other one ran off of actual crankshaft speed. But the upper droop and lower droop had the meaning of what was your governor delay. Nobody could explain that to me very well. One of the things I've learned over the years as far as teaching and instructing people that they lose an awful lot in translation. And if you don't understand immediately, they get stumped. We're talking going way back. I asked somebody one time, and simple thing, why he pumped his air compressor up, and I was a kid, 9 years old, 10 maybe, and I didn't have an understanding of why in the world he was going out to put air in a tire with 120 pounds air pressure. I was like, you're going to blow the tire. And he says, no, it won't. It's volume. And I'm a kid at the time. So what's that mean? Just volume. And I kept looking at him. Yeah, but the pressure's high. But it's volume. And that's all I kept hearing. It's like, I can't understand what you're saying. And the simplicity of it is I have high pressure in the tank to create enough volume in the tank to fill the tire to 30 psi to be able to get on the road safely. And I would have sat there and said, what do you mean by that? So, well, the air is compressed in here, just like air we breathe. That's compressed. When we release it in the tire, it's no longer compressed until the tire starts to inflate. And then I can stop it at 30 psi. To me, it was you have so much pressure in your water system in the house, you turn that on, that's pressure come. No, he was just saying volume, but the two work together. Well, this is the same idea with a governor, explaining the difference in upper droop and lower droop and what's going on here. Road speed is a whole different thing. Road speed, you're buzzing down the highway and you're still operating on governor control, but it's by governing the engine by what's happening on the ground. So while it's looking over here, what your speed is on the road. It's telling the engine what to do, and that's within the working range. The working range of the engine. The funny thing that's hard for a lot of people to get used to as well is the N14 in some cases would rev up to 23, 24, 2500 RPM. Had a taller block, a longer rod, which meant had less stress on the piston. Well, when they stopped building the N14 and came out with the ISX, it was a short block, short rod, and they had to keep the stress off the piston. They limited that 2,000 RPM, 2,100 RPM. Its rated speed was 1,900. Well, the N14, they could turn that up to rated speeds of 2,100, 2,200. But the actual torque was 1,400 or 1,500 RPM. So now you have another thing to add into your equation. When I'm talking here about upper droop and lower droop, let's transfer that from the road speed side and come over here to commercial, which most of that, what I deal with in the past few years, has been construction and later agricultural. And you're looking at the engine RPM. In other words, you set an RPM, you want that, but it needs the power to do it. But they have to calculate into that your droop. Well, what's the droop in this case? In your old tractors, the droop on the mechanical governor is the mechanical friction and the sensitivity of the governor. Now, some of the tractors, like with the Continental engines and similar, on the end of the camshaft, because there's so much space, they figured they'd make a nice big governor, and that would really be reactive. Well, the problem was that there wasn't enough RPM off the camshaft. The engines were only turning 1,500 RPM, 1,800 RPM. Well, what's that mean? The cam's turning half that speed. So at 1,500, 750 RPM, oops. Yeah, that's not going to be very reactive, is it? And to give you an idea of sensitivity, the RPM droop of such engines with that kind of governor turning slower meant it was less sensitive to changes. Well, on a long stroke, slow engine, the problem they had was that by the time the governor turned the engine on, the RPM had drooped so far that it was coming on with a vengeance. My Ferguson's like that. The power just comes on and barrels, and it goes. But it'll come up and it'll, now as they called before, the upper droop is how far over speed it would go before the governor would react and come back down. So that's where we're talking about in the electronic side, upper droop and lower droop. Well, bring it over to mechanical, same idea. How far it went over because of sensitivity, and then brought it back to the RPM that was there. So you'd be driving along and hearing this engine going, and then finally the governor would kick in and come back down. To avoid that, Ford put the governor on the end of the crankshaft. And I was listening to, I can't remember the generator company years ago, but my uncle was reading the specs on the governor and found out that the only tractors recommended, gas engine tractors, to hook onto that generator were Ford tractors, because their governors on the crankshaft is sensitive enough to keep the speed variance within a range that the generator could handle without causing spikes and blowing out light bulbs and other equipment. And this is before the electronic age. They were concerned about it. If you had a constant load on it with a tractor that had the larger camshaft governor, it didn't make that much of a difference. So, upper droop, lower droop. To get into the discussion I had with Wayne Van Wee, that gives you an idea of what I'm aiming at here. He sat one time and he says, we were talking, and he and I talked quite a bit, apparently because the OCD tendencies from my family upbringing, which wasn't necessarily good, that's for sure. But at this point, it did work out to my advantage because I wanted to know certain things, and I was one of those kids that didn't accept a non-answer very well with, you'll figure it out later. I'm sitting there thinking, in my mind when I was younger, like, no, I need you to teach me now. And they'd say, you're too young, and just pass me off. The problem was I wasn't too young here because of my upbringing caused me to be more analytical. It happens with a lot of kids that become mechanics and technicians, and the families just pass them off until later. There's something wrong with you. You just don't understand. No, the problem I didn't understand was, why didn't you spend the time to teach me? That's what I didn't understand. So Wayne was one of those that we'd sit down and talk about this stuff once in a while. It'd be on break or whatever between bus runs. and such. So he says, I don't know why it does it. Just says you lug the engine down, and it comes to a certain point, and the governor doesn't correct anymore. Well, that's pretty much where your horsepower is. If your engine's wide open at full throttle at 2,200 RPM, well, rated speed's usually 2,000. And we were talking these things over, and he says, but I don't know why it doesn't correct. You would think it would try to stay at 2,400. And at the time, I had it figured out, but I was so busy with many other things. And you go home to a nasty environment, and it'd slip your mind. And I told him I figured it out, but I can't remember what it was. Here it is, droop. They call it upper droop and lower droop. Well, it isn't droop so much as it's underspeed and overspeed of the governor. And when you put it on dynamometer and you start putting the load on, you'll be up wide open, say 2,200. And then you start to put a load on, it'll do one of these. And then you put another load on, it'll do one of these. And if you watch it carefully, it'll keep coming. And then suddenly it'll do this and this and this and come down to your 2,000 RPM rated speed. Dynamometer we had, your PTO would not be at the actual 540 RPM when it reached its loaded RPM. There's full RPM, full throttle, unloaded speed, and there's loaded speed, and that's how they rate the engine, but you're on the PTO with a dynamometer on tractors. And he says, I don't know why it doesn't correct. Well, it finally hit me, and I was laughing about it a year or so later when I got out of bow season. I was in college, and we didn't run the dynamometer there much, but we were mainly focused on repairs. But I started laughing when it hit me. I said, I wish I could have remembered to tell him what that was. The governor hit the stop. I said, what do you mean? The governor hit the full extent of its travel. In other words, on a gas engine, the carburetor throttle was wide open. There's nothing left. That's it. And on a diesel, the governor in the pump is set at a certain amount of fuel stroke to send into the engine as a maximum. It stops. That's it. It's over. So 2,200 RPM to 2,000 RPM, that's all that's there mechanically on those engines. And the same in the electronic, only it's in the computer design. And then there you can change it slightly, your upper droop and over droop, but not that much. There's just a little range they give you to play over. Why do they do it in the electronics? Well, on the road, for road speed, it would save fuel. It's not making any adjustments. So if you changed your upper droop and brought it down so that it didn't overspeed very much when you were going downhill, and the governor correction would come right in, it'd start shutting the fuel down. On the lower end, when you hit the fuel, okay, now this is, you're operating at an RPM, and they're talking about how far it can overspeed before it corrects, and lower droop, how far it'll underspeed climbing the hill before the governor corrects. And that would bring this one down and this one down. So you got a little bit of a range here and a wider range here. Then the engine comes in, goes further up the hill without burning as much fuel, gets it closer to its torque peak, and then the fuel starts turning on and goes on up the hill. And you say, that's not very efficient road speed wide. Well, it's not. Bring that over here and you don't have so much control. You're looking for on the agricultural, commercial, constant speed governor side, you're looking for this. You're not looking for this range anymore. If you understand what I mean. On the road, the changes don't affect so much. But out here where you're trying to run something generally at PTO speed or a particular ground speed, now it becomes a little more critical. But the idea here is you're under full load. So say you're chopping corn and your tractor is just about the right size for that chopper. Well, now you've got a new problem. You're near the maximum of that governor before, electronic or mechanical, before it hits that limit of lower droop or lugging. Well, now it's near wide open and you start climbing the hill. There it is. That's it. You're at its limit. It can't do anything else. But the engine speed keeps coming down, and as it does, pressure in the cylinder increases, so your power output is still going up. And you say, how in the world? Now, on a gas engine, the piston's moving slower, but still at a pretty good rate. Well, what just happened? You have a slightly slower engine, and it's in the milliseconds or less. You have a longer time to fill the cylinder with a gas air mix. So it's still slight increase of power. On a diesel, oh, this is a huge boon on a diesel. Why? Well, because as that pump is turning and that little piston's coming back and fuel is being forced into it before it shoves back up, now you have more time to put more fuel in there. Pressure time, as Cummins used to have it. They had a system designed with orifice in the injector, calibrated to the injector output and to the pump and the RPM of the engine. And it'd have a maximum input to it, but pressure time. In other words, everything's at max, but as the engine slows down because of that orifice, it has a lot longer time to get fuel in there. And on the diesel, your distributor pumps, your inline pumps, your in actual full injector body pumps on the engine, that is how that often works. You have more time and it automatically increases in your engine, and nothing has changed except your engine's turning slower. But more fuel's going in, so your torque increases. So this is some of the things that come where your governor is done, but that little diesel still seems to have more power. How is that? Well, that's how. As the speed of the engine slows down, there's more time to get fuel into the injector or in the injection pump. You get more fuel sprayed into the engine. Works out great. And you say, yeah, but what's your whole point? My point is that when we're talking about the governor has done its maximum, and that's where your rated speed is when that governor just about, either just about or does hit the stop, it's all over, but that's your rated speed. That's not your or rated speed and rated full speed, rated loaded speed, and your rated horsepower is here at the governor stop on almost every engine ever manufactured, electronic or mechanical, either one. And after that, what happens is because the engine's slowing down, more fuel is able to enter the system. And of course, your electronic system is going to occasionally, it'll have a boost. So that'll pump in a little more fuel. Mechanical system, it just happens naturally. As the engine slows down a little bit, more fuel is able to get in to fill the pistons in your pump or in your actual full body injector that's getting fuel in it. But the same idea. It's either a distributor pump, inline pump, or the pump is in the injector. Full body injector, full injector. Same thing, time. More fuel to fill that chamber before it injects. What do we call that? And now they call it power boost and some other names to it, but the actual power idea we had originally was torque rise. Horsepower ran out. That's right. You hit rated speed, you pretty close to maximum horsepower. It might go up a little bit after that, but you're at rated. I said, well, yeah, but no, you're rated here. You get a crazy tractor like a 6060 Alice Chalmers, 6080, the 7700 Ford, 7000 Fords, and some of these others. International did a great job without turbochargers the same way their system was designed. I saw a 454 International put out almost the same torque as a 65 horse Alice Chalmers tractor because it would fill up with more fuel, put out more fog, and that sucker was pouring it on. Little 3-cylinder, I mean, torque. It's a long stroke German engine. Oh man, did it put it out, but it was long past the governor stop to put that kind out. So it was overworked, over fueled, but it had the power. So they ran it on a blower. It was a little 45 horse tractor and a 60-foot silo. Was it? And 50 and 60-foot silos. Like, how in the world? He says, I don't know, but it does it. Wow, that thing ought to be running wagons. He says it's not heavy enough. It had the power enough, but it wasn't heavy enough with a big enough tire to safely run the wagons. So he ended up on the blower. That's the idea of what we're talking about with your governors, Governor Droop, and whatever else. Let me see if I can bring it down and bring it to a conclusion for you. The governor has an general overspeed setting and a general lugging underspeed setting or rated load. So rated RPM full, rated RPM full load, and then it'll have an RPM for full torque of the engine. And they're different settings. But between full RPM and full horsepower load, that's where the governor is against its stops. And from there, you lug it down, the RPM goes down, and in an internal combustion engine, what does that mean? There's more fuel, there's more time for air. In a gas engine, same thing, but in a different way, fuel-air mixture coming in. So it'll continue to increase, plus the design of the engine, the ports, and all of that stuff. Or turbocharged, and it works for both naturally aspirated and turbocharged, but turbos, oh yeah, You put more fuel in, and that means more air in as well. So they have to design it with wastegates or just have the turbo designed for the appropriate size to bring it to that full torque value. What's the limiting factor? The limiting factor here is how much stress can that engine take? So they have to stop it at some certain point. And with electronics, that's easy. They put an algorithm to say, yeah, you can go up this far, and that's it. Some of the trucks that I used to drive, they used to have what they called ST2. And it was their way of saying it's something torque 2, meaning top 2 gears. So I had a truck one time, and I was driving around with an M11. And I drove around the corner and stepped on it, and that T2 kicked in, and I was by the railroad tracks at Cummins, and it skipped right across the railroad tracks, and I had a hard time bringing it back, and I couldn't get my foot off the throttle fast enough. Within 2 seconds, I had the thing almost sideways. It hit full power, full torque, everything the engine had, and the thing I didn't realize was I was down low enough in the RPM range, I was at full torque RPM. It just broke loose. So the designs of this stuff are interesting, but why they do it at top 2 gears is so that it doesn't happen in any other speeds. It happens when you are under a load. Your engine is up at RPM, and the higher the RPM, the more output they can have, mainly due to vibration. Because if you run an engine down towards full torque, there's a lot more vibration that comes into the engine. And sometimes, let me tell you, that's cool. Now you say, how do you prove this? Well, the way I proved it years ago was, like I said, that 454 International. No turbo, but because it kept pumping in more fuel, that 45 horse engine turned on the torque like it was almost 60 horsepower. It was an animal. I found out later on it was like 15 or 20% torque increase, which we called torque rise. 6060 Alice Chalmers was rated at about 65 horsepower. But the torque rise meant most of those tractors, especially the early series, before they started putting pin numbers on them, the early engines that had the crankshaft trouble, that was a 95 to 100 horsepower engine, actual honest horsepower, because the torque went up so fast, even losing RPM didn't make any difference. It increased the power. Horsepower is rated by torque over a particular time, meaning RPM, revolutions per minute. So torque is just direct shaft twisting, just like you had a torque wrench and you were pulling on it, it said 100 foot-pounds of torque. Well, if they had that on a dynamic reading, you could have 100 foot-pounds of torque with a spinning shaft that's able to create that through the gear train, through the dynamometer. So that's the similar idea there. 6080 Alice Chalmers was 25%, and a lot of those are rated 85 horsepower someplace in there, roughly, give or take. And on the dynamometer, I had seen them put out 125 torque rise. They're insane. 7700 Ford, 7710, 7700 Blue Power Specials, they're all excellent at this. Well, I'm done for now. It's time for me to go. Catch up with you folks later at the next brainchild I get.